Hello students, welcome to Web Studies, and today we will be covering variation of pressure with depth inside a fluid under the chapter mechanical properties of fluid. Fine. So in this topic, this is very important as per the JEE Mains perspective as well as JEE Advanced. So this is very obvious that we can say that the deeper a person travels into a liquid or a gas, we can say the higher pressure exerted on him by the surrounding fluid. Fine. So the reason for this increasing pressure is that deeper a person goes into a fluid, the more fluid he has over top of him. Fine. And therefore the more weight he will gain or he will have basically. So for this variation of pressure, we have the equation as P equal to rho gh. Here P is the pressure exerted by the bottom of the container. Rho is our density of the fluid. G is obviously acceleration due to gravity. And h here, it is the height of the fluid which is filled in the containers. Starting from the bottom up to which the fluid is filled in the container. Fine. Now, why are we studying this? What is the importance? So this variation of depth in a fluid, it is basically telling us that how pressure is increasing with depth in a liquid or a gas. Apart from this, we have to keep some points in mind for proper question solving. So very first point is this pressure, this variation of pressure, it is created by the fluid weight. Fine. And beyond a specific condition under which it is derived, the equation has generic validity. Fine. Also, the surrounding fluid would exert this pressure even if the container was not there, keeping this fluid static. Fine. Apart from this, this equation remains true to deep depth for fluids that are practically incompressible fluid. Fine. And this equation, it is used for gases that are very compressible as long as the density of variations, they are minimal across the depth covered. Fine. Now let us see the derivation of this. So here, as you can see, a container is there. So just see this figure. The weight of the fluid inside it is basically supported by its bottom. Let us see how much pressure the weight of this liquid exerts on the bottom. Fine. So weight of the fluid we can write as mg, W equal to mg. Height is given as h. Area of cross section is also given. Fine. So weight of the fluid is basically mg divided by the area, which is equal to pressure. Fine. So we can write now weight of the fluid, that is W. W is equal to here mg. Fine. Then mass of the fluid, it is equal to the product of volume and density of that substance. So mass, that is m mass, this is equal to density, that is rho, into volume we can write as v. Fine. Then this volume of the fluid is also equal to the dimension of the container. Fine. So this volume v, this will be equal to dimension of the container. What is it? So area of cross section into height up to which the fluid is filled. Now we will combine these equations and write. So from these three equations we can write that W, that we can write m, that is mass, is equal to rho into A into H. We can write, combining the equation 2 and equation 3. This will be our equation 1. So we have done this. Now from equation 1 we can write that weight, it is equal to mg. So it will be equal to rho into A into H into G. Now pressure that is exerted at the bottom of the container, that pressure P, it will be given as I said in the beginning, weight upon area of cross section. So just put the value rho A H G divided by A. This will be equal to rho G H. Therefore, we have our equation, that is P equal to rho into H into G. Fine. So this is a very simple derivation. Now let us solve a question based on this for better understanding. So here is our first question. We need to calculate the force exerted by the water on the base of a tank of area 3 meter square, 3 square meter basically, when filled with water up to a height of 2 meter. We have been given the density of water as 1000 kg per meter cube and the value of acceleration due to gravity, which is 10 meter per second square. Fine. So firstly, we have the depth of the column, which we can say as height. Height is given as 2 meters. Fine. So height is given. Apart from this, we have density of water, which is basically rho, and rho is equal to 1000 kg per meter cube. Fine. Now, from the formula, we know that pressure is equal to rho into gh. Just put the values. We have 1000 into g's value, that is 10, into h is 2. Fine. So, if we calculate all these, we are going to get 2 into 10 to the power 4, and the unit of pressure is Pascal. But now we have to calculate the force also. So we know that the formula of force, F is equal to into area. Pressure we calculated 2 into 10 to the power 4, and area here is cross sectional area, that is 3 meter square, 3 square meter basically. So calculating this, we get 6 into 10 to the power 4 Pascal. But here we have force, so we cannot write Pascal. The unit of force is Newton. So 6 into 10 to the power 4 Newton we will have. Fine. Now let us solve one more question. The question is, calculate the average density of the atmosphere given that it extends to an altitude of 120 kilometers. Fine. So here only one data is given. The rest of the data we need to have. So firstly, we know that the our equation here used will be pressure equal to rho gh. Fine. And we have been asked for density. So rho is equal to pressure upon gh. This will be the formula that we will have to use. So here P is our atmospheric pressure. So atmospheric pressure, the value of atmospheric pressure is 1.01 into 10 to the power 5 Newton per meter square. Now we need to have the value of G. If nothing is given, just take 9.8 into 10 to 9.8 into meter per second square. Fine. Now the altitude value of H, it is given 120 kilometers. So 120, we need to convert it into meters. In order to do that, we have to multiply it 10 to the power 3. We will have it in meter then. Fine. Now, since we have all the values, we can put in into the equation and get the results accordingly. So 1.01 into 10 to the power 5 by 9.8 into 120 into 10 to the power 3. Fine. So if we calculate all these, we are going to get 8.59 into 10 to the power minus 2 we will get. And the unit will be kg per meter cube. Fine. So I hope you understood this question also, and this whole concept also of variation of pressure according to the depth in any fluid. So thanks for watching and thank you.